Hello guys, I am Ryan M. Oliveros, and for today we will be doing experiment 13, asynchronous counter. For our experiment, we will be using IC 7493, which is a 4JK flip-flop, an 8-bit counter. So here we already have a 4JK flip-flop, a NAND gate, 6 LEDs, 1 clock, 1 power supply, and 2 switches. So let's try to simulate our experiment. First, let's connect the clock pulse to the clock input. Next, let's connect to the key output to the LED, followed by connecting the key output to the clock pulse of the next JK flip-flop. Then repeat the same steps. So here we have our clock pulse with the JK flip-flops. So next is guys, let's connect the supply to the J input. Ayan. So here, J, K. So it will be a toggle on since it has a logic 1 level for both J and K. It will act as a toggle. Next, for the NAND gate, let's connect it to the clear. Now that we've connected it, let's connect the into to D1 and D2. So we've finished constructing our circuit. Now let's try to simulate it. First, let's put D2 as a logic level 1 and D1 as logic level 0. As you can see here, the LED directly connected to D2 is on logic level 1 since it has a logic level 1 input, it will be the same. Next, let's try to run it. See here, here's the pattern of the LEDs. After it finishes, it will reset back to 0. So here we have the timetable of the logic DR circuit. So this is on the top, you can see here, this is for the first. So here we have the first, for the first JK flip-flop, it's 0 1 0 1 0 1 0 1. So see here, it's with 0 1 0 1 0 1 0 1. For the next, it has a delay of 0 1, then 0, then 1, then back to 0 again. It takes longer and longer as more JK flip-flops are connected. So that's for our circuit. Next, let's try if we switch on D1 and D2. So here, let's switch on D1 and D2. If we switch on D1 and D2, the counting stops because for the NAND gate, this is actually equal to 0. If both inputs are 1, then the output will be 0. If the output is 0, since it's connected to clear, automatically, so it will remain as the same. It will retain since it clear is equal to 0. So what if we move the clock pulse to the second input? So let's try it. Let's reset. Then let's move it to here. So as you can see here, if we move the clock pulse, let's try to run it, then it will start at here. So you can disregard the timetable since here we only have 3, since the first one is not included. So that's it for today. I hope you guys learned, and thank you for watching.